Today we will discuss the electrochemistry. So what means of electrochemistry? When they take the reaction, when go to the reaction formation products, right, that releases some energy. So when the reactions conversion to products, the formation of energy, this energy will releases as an electric current or electrons or electro energy. That is called electron reactions. When the reactions converts into products, we bring out the some energy, the reactant convert into the products. This type of reactions also we call electrochemical reactions. Once again I repeated that, when reacted to formation products and releases some energy, thus energy is electron or electrolysis or electrical energy. Third is called electrochemical reactions, or the reactant formation product, the reactant ready to formation product, we give the some energy. That energy is the electric energy, right? When they give the electric energy, the reactant convert into product. This type of reactions we call electrochemical reactions. This is used for some operators. That operators we call electrochemical cells or electrolytes, electro cells. Yeah. Electrochemistry. When you measure the reactions converted into product, the use of some cells. That is cells we call electrolytic cell. I can define that one. How is it working? How is it using that reaction to convert into products in electrochemical cells? First we see that one. And take the ones or glass, something of a cell-like cell that one, and fill with the electrolyte. Some of chemical solution. Some of the chemical solution we call electrolyte. And next one dip with the two electrodes or metal rods. The rods are, I am giving this right side is the minus sign and left side is given the plus sign. The minus sign is called cathode. The minus sign cathode is attached with the battery. Okay. The cathode attached with the battery, that is the negative side. And anode, the positive charge. This is attached with the battery, positive side. So this is filled with the one cell. And when the two rods in dip with the one solution, this is the electrolyte. Electrolyte, what means of electrolyte? The when the passing the current, when the on the switch or current, when the pass the current in the electrodes, cathode, the electrolyte decomposed formation some resultant product. When the passing the current electrolysis decomposes to formation the result on the formation on the passage of current. That solution we called, or that substance we called electrolyte. And next, when the electrocells electrolytic solution, totally this one, right? When the passing the current, the electrolyte solution converts into electrolysis, go to the electrolysis. This phenomenon is called electrolysis. When the pass the current, the electrolysis decomposes the formation product. Total of this substance, total of this reaction we called electrolysis. Total of the cell we called electrolytic cell. Faraday first law. Explain on the basis of the electrolytic cell. What is the Faraday first law? The Faraday first law is explained by the passing of current. The passing of current depends on the formation of, an example is the formation of, when the pass the current in the electrode, the electrolyte solution is liberated or decomposed. Formation some of the product like the electrode are deposited this electrode. So the deposit the electrode depends on the quantity of the flowing of current. That equal to W means the deposit of product. The deposit of product is equal to W. That work function we call, the W is called work function. Work function means the deposit of metal or product. It depends of or proportional to the length of the fluence of current, the strength of current in presence of time. That means quantity of current, given the quantity of current, the formation of the formation or deposit of the metal is more. When the metal is deposit the more, na, the take of the current is more. That means I am write like this, na, I equal to into T into Z. Z means the constant are known as the electrochemical equivalent. That I equal to the current of strength in ampere. They give the amperes. T is equal to time and seconds. Right now, totally Q is the I into T. We mentioned Q into Z. Totally W is W directly proportional to Q into Z. When the current of strength, I am taking the 1 ampere. No? When I take the time, they taken 1 second. Therefore, is converted into Q and coulombs of current. The quantity of coulombs of current equal to 1. Therefore, W equal to Z. They convert into W equal to Z. This is the Faraday's first law. Faraday's second law. The Faraday's second law explained by the when take the different electrolytic solutions. When we take the different electrolytic solution, we pass the only same current. The passes of the same current, no different the current. The passing the same passes of the current in the different electrolytic solution. When the deposit the product or deposit the metals, that depends on the solution of chemical equivalent. The solution of chemical equivalent and depends on the liberated of electrolytic solution. For example, we take the mass of A and mass of B. The mass of A electrolytic solution and mass of B is the electrolytic solution. That is, formation of the mass is equal to chemical equivalent of A and chemical equivalent of B. Therefore, that equal to M1 by M2 equal to E1 by E2. That means Z. Z is, we know that one, chemical equivalent of A and chemical equivalent of B or chemical equivalent weight we call also. So directly I am writing Z1 and Z2. This is a Faraday's second law. What is the means of Faraday's second law? When the same current passes to the different electrolytic solution, the deposit of metal or deposit the product at cathode, that depends, that directly proportional to liberations of electrolytic solution depends on the chemical equivalent weight of the electrolytic solution. That is the mass of this solution. Okay, na? Calculate the quantity of electricity would be required to reduce 12.3 grams of nitrobenzene to aniline if current efficiency is 50%. If the potential drop across the cell of 3.0 volts, how much of energy will be consumed? The problem is the nitrobenzene. We take the nitrobenzene. I'm sure this nitrobenzene and NO2. It's good to reduce. What is the nitrobenzene to aniline, convert into aniline. I take the hydrogens and plus 6 electrons. The conversion I can write like this. Right. And H2. Right. This is conversion of the aniline. The nitrobenzene is to go to reduce the aniline. What is the efficiency? Is the 50%. First of all, we see the nitrobenzene of chemical equivalent. What is the nitrobenzene of chemical equivalent? Chemical equivalent weight equal to 1 Faraday equal to 96,500 coulombs. This is obtained from 1 Faraday equal to, how to calculate the 1 Faraday? No? 1 Faraday equal to the quantity charge of electrons and 1 mole of electrons. That equal to, we take the 96,000 by 500 coulombs. So that equal to, I am write like this, right? 1 Faraday equal to the quantity of charge of electron 6.0.23 into 10 to the power of minus 19 and into 6.023 into 10 to the power of minus 23. That equal to 1 Faraday equal to 96,500 coulombs. Right, we operate from this one. So I'm substitute the values. What is the weight of the 12.3 grams? Right, I'm write to 12.3 grams and equal to, what is the chemical equivalent to 123/6, and I'm write the into I into T by 96,500. Can I draw? Alright. We already given efficiency is the 50%. So I'm write like this: Q equal to I into T. Alright, now the total Q is equal to 11,013,500 coulombs. This is the total answer. Right, this is complete. Right. Okay. Alright. Before we see the electrolytic cells, see another cells. These cells are called electrochemical cells. These electrochemical cells we call Daniell cells. What is the Daniell cells? We take the different solution in different beakers and we dip with the two different rods. The rod is made with one is the copper and one is the zinc. The solution is the first solution is the zinc sulfate and second solution is the copper sulfate. The reaction is completed with salt base. They prepare by potassium nitrate or potassium chloride. So the total of cell completed with the salt bridge. So right, we see this one. When the chemical reaction, when you see the EMF, Z into left go to the left to right. When you go to the left to right, Zn convert into Zn plus plus and copper plus convert into copper. How to this one? Zn, when the start the reaction, Zn loss of 2 electrons. Zn or zinc loss of the 2 electrons. The formation is the 2 electrons go to the copper rod. Right now, when the loss of zinc sulfate to formation is zinc plus and zinc oxidations or zinc ion. When the loss of the 2 electrons of zinc is called oxidation. Right now, the 2 electrons are carried out to the copper. The copper solution. Copper solution accept these 2 electrons. Formation copper. Right now, copper. This is called reduction. That means zinc, when the losses of the zinc 2 electrons are we called oxidation. Copper, when the accept the 2 electrons go to the copper metal, is called reduction. The LHSF or zinc is the zinc plus is converted to 2 electrons. This is called off reaction. One of the off reaction. This copper plus 2 electrons is the formation the reduction. This is one of the off reaction. We totally write the full reaction is the zinc. Right now we take the zinc. When they take the zinc, they treat it with the copper plus plus. The total reaction, I will explain the total reaction. Zinc treated with the copper plus, double plus, no? The formation of zinc double plus. When the zinc losses of 2 electrons and copper, the 2 electrons and accepted formation copper. This is the full reaction. This is the electrochemical cell. 1.1b is the difference between the copper and zinc. Potential different. This is the 1.1b. When the EX means external potential different. External potential different when equal to 1.1b volts, no, the reaction is not occur. That means electrons not follow the copper sulfate or copper sulfate electrons not follow the zinc sulfate. When the external potential difference less than 1.1 volts, no, zinc the electron transfer to zinc sulfate to from copper sulfate. That means if potential external more than the 1.1b, so copper the electrons transfer to copper rather to zinc. This is called opposite potential. This is called opposite external potential. This is the complete.